Today, we're looking at something really cool called ELHPlan. It's basically a whole new way to get teams of robots to work together and to do it super efficiently.
So here's the big question, right? How do you get a whole team of robots to cooperate on something complicated without it turning into total chaos? Or, and this is the big one, without it costing a fortune in computing power?
Okay, to really get this, let's bring it back to something we can all understand. Picture this. You and a friend are trying to cook a huge, complex meal together in the kitchen. You've got to figure out who's chopping, who's stirring, the whole deal.
So the old ways of doing this kind of fall into two camps. First, you've got the declarative plan. Think of this like having the entire recipe printed out step by step before you even start. It's great, it's efficient, as long as nothing goes wrong. But it's totally rigid. Then, on the flip side, there's the iterative plan. This is like you're on the phone with a chef, getting instructions for every single tiny action. Pick up the knife, now chop the onion. Super flexible, right? But man, is it slow and just a ton of back and forth.
All right, let's translate that back to the world of robots. That constant phone call method? Well, for a robot, every single one of those steps means asking a big AI model, what do I do next? And each question costs something. We measure that cost in tokens, which you can think of as computational currency. It costs real time and real money. So you're stuck with this awful choice. Go with the cheap, rigid plan that might just fall apart, or the super flexible plan that's way too expensive to actually use.
And this is exactly where ELHPlan comes in and changes the game. It introduces this brilliant new idea that tries to get the best of both worlds, the efficiency of a full recipe and the flexibility of that step-by-step call. The core of it is something they call the action chain. So what is an action chain? Well, it's not just one tiny step, but it's not the whole rigid plan either. It's the perfect middle ground. It's a chunk of related actions all tied together with one clear mini goal. It's a really smart way to bundle tasks. Let's jump back to our kitchen example. Instead of telling your friend, pick up the knife, now chop the onion, you give them an action chain. You just say, hey, you're in charge of prepping all the veggies for the salad. See? You've given them a clear goal, but they have the freedom to figure out the details. It's a complete thought, a whole subtask.
But here's the thing. These action chains don't just exist in a vacuum. ELHPlan has this really clever 4-stage cycle that's always running, always checking and fine-tuning the plan. Let's walk through it. Okay, so first, the system constructs the plan. It creates all the action chains for the robots. Then, and this is the really brilliant part, it validates them. It looks ahead and tries to spot any problems before they happen. If it finds a conflict, it moves to the refine stage, where it actually fixes the plan on the fly. And only after everything's been checked and double-checked does a robot actually execute its task. It's this constant smart loop. Plan, check, fix, do. All right, let's watch this in action. Picture two robots. Their job is to collect fruit. And in the first draft of the plan, both of them are told to go grab the exact same apple. Uh-oh. That's a classic problem, right? A conflict waiting to happen. This is where the system is just so smart. In that validation step, ELHPlan sees the problem. It realizes, hey, two robots are going for the same thing. And the key here is that it catches this before anyone even starts moving. No wasted time, no wasted energy. That proactive thinking is a total game changer.
So then we hit the refinement stage. The system basically says, okay, robot 1 has the apple. Robot 2, let's change your plan. Forget the apple, you go get the loaf of bread instead. And just like that, the conflict is solved. Everyone has a clear job, and the whole operation just keeps humming along.
Okay, so the idea sounds great, right? But does it actually work? Well, the results. The results are where this gets really, really impressive. Let's look at the numbers. So they put it head-to-head with another top-tier method called RVECA. And look, the success rates are pretty much the same. Both systems get the job done really well. But check out the token cost. That's the computational price tag. RVECA burned through more than 72,000 tokens. ELHPlan, not even 18,000. It's a huge difference. Let me just put that in a different way for you. 24%. ELHPlan did the same job just as well using less than a quarter of the resources. We're not talking about a small tweak here. This is a massive leap forward in efficiency. And this chart just makes it so clear. That big bar on the left, that's the cost of the old way. And that much, much smaller bar on the right, that's ELHPlan. The difference is just staggering.
And that kind of efficiency is what takes an idea from a cool sci-fi concept and makes it something you can actually build and use in the real world.
Which brings us to the big so what? Why does any of this matter once you step outside the research lab?
Well, this is the key. This kind of efficiency could finally unlock the door to having huge teams of robots working together. I mean, think about it. Massive warehouses where everything moves in perfect harmony, or teams of search and rescue bots swarming a disaster site, even fleets of self-driving tractors working a farm. All of these things require tons of robots to coordinate in really messy, unpredictable situations.
What ELHPlan really does is it breaks down a huge barrier, a cost barrier. It makes coordinating robot teams computationally affordable. And by doing that, it opens the door for us to create autonomous teams that are bigger, smarter, and way more capable than anything we've seen before.
And that kind of leaves us with a pretty big thought to chew on, doesn't it? As these super efficient robot teams start to become a real part of our world, the challenge isn't just going to be how do we make them work? It's going to be how do we make sure that what they're working on is what we want them to be working on? How do we keep their goals and our goals perfectly in sync?